Hello everyone, my name is Alesh. I'm from the Kunobi team. Today I'm going to be presenting a tool that's called Kache, and yeah, it caches. And it's a tool that we've been using internally, and we have decided to open source so that it's available for anyone to use. And if you want to see how it works, well, then just stay in the video because we're starting right now. So why do we need this anyway? I mean, Cargo already is caching things, right? And yeah, it is. But it's like for a very specific use case that we have built cache. And what happens with the Rust standard compilation is that it works for a single workspace, and it creates a target directory in that workspace. And then when you compile something and you recompile it back in the future for the same workspace, Cargo knows where to check, and it goes to the target directory and it sees that the compilation artifact is already there, and then it just doesn't rebuild it again because it already has that. Well, what Kache is doing, Kache with K, our tool, is giving the compiler a way to know that a piece of code that's identical to the one it is going to compile now has already been compiled, and then it can just grab the artifact from there, and there's no need for it to recompile it again. But what happens if you have multiple workspaces? And let's say, for example, you open a new Git worktree and you're working on two places at the same time. As you can see, the way the flow works is pretty simple. We just check for the keys in the two caches, either the local one or the remote one, and then we take some action based on the result. The first cache that we check is the local one. And if we actually get a hit, which means that the code that we are about to compile has already been compiled, then we create a link that goes in the target directory inside the the workspace that we're working with, and then Cargo knows where to get the file from. And this way we are not moving any bytes, we're just creating a link, which is actually much more lightweight than moving the entire file around or copying it or whatever. And the second option that we could have, if the local cache is a mise, is to check the remote cache. And essentially the same happens. We would create a link in case of a hit, and we would just go to the next sequence of the diagram if there's a mise. Well, if we get two misses on the cache, which is the other option that could happen, then what we do is we create a new key in the cache so that in the future, if this code is compiled again, we can just grab the artifact. And then we just pass the arguments along to rustc, and we let it compile as it would do if there were nothing in between. The way the cache key is created is by using the Blake 3 hashing algorithm, which you don't need to know. It's just a common hashing algorithm. And what we do is use as the input for the hashing algorithm all of the things that are particular to the specific piece of code that we are about to compile. And then what we leave out of it is all of the things that are specific to our machine. And what this accomplishes is that we can share these cache entries across machines. So this time, when you put something in the cache, it means that someone from another machine can use it, a CI runner can use it, I don't know, anybody from any machine can use the cache entry that you uploaded. And this makes it really cool because this means that you can save time, not only in your machine, but in every machine that you can come up with. Regarding how the tool actually works when you run the cache monitor command is, I think, really simple. To get the gist of it, you will see a TUI that contains a lot of stats. I'm not going to live demo because I don't want to spend too much time and I want to keep the video short. But I think it's fun to see at least once. You get like this live build panel in the middle, and you can compile something and you'll actually see live if you're getting cache hits or cache misses, and it's cool to see. Lastly, I know that I have talked about a little bit about remote caches, but I have not actually explained them. And the thing is that you can configure this yourself, and it is compatible with any S3 compatible backend, and you just configure it, and then your remote cache is working, and your laptop can, or your CI runner, or whatever, as we mentioned, any machine that you want, can pull things from the S3 bucket, and you don't have to recompile them. And now this presentation has come to an end. I hope you liked the video. I hope you liked the tool, and I'm sure you will be at least trying it, and you'll see that it brings down your compilation times a lot. And we from Kunobi really hope it's useful for you. And if you have any feedback on the video or on the tool, or even if you want to try Kunobi, then just reach us out. Have a good day.